All right, so I'm back again. And here we're going to look at the second objective, which says that we're going to evaluate a linear function from a word problem. So we're going to take a word problem. All right, we're going to take a function and we're going to take the word problem and try to evaluate it. What do I mean by that? All right, so let's go into a couple of the examples and you'll see what we mean by that. All right, so first example here. All right, it says we're evaluating a linear function from a word problem. All right, so it says this equation shows how a sample height depends on its edge. All right, so here the height is depending on the edge. All right, it's just we breaking it apart. So here it says edge is equals to 3a. Edge is equals to 3a. What does this mean? It says the height is equals to 3 times the edge of the sample. All right, the height is equals to 3 times a, and a here represents the edge. All right, so now it says, here it says, how tall was the sample when it was 5 years old? Again, we know that years is represented by a. All right, so years is represented by a, and we have 5 years. So here I'm going to substitute 5 for a. So edge is equals to 3 times 5. Again, I substitute 5 for a. All right, so edge is equals to 3 times 5, which is 15. So what is this? This is saying that height is equals to 15 inches. All right, so at age 5, the sapling is 15 inches tall. All right, so all of this is part of our answer. At age 5, the sapling is 15 inches tall. All right, boom, easy. Let's go to problem number 2, or example 2. Here, on example 2, we have what? This equation shows the time required to ring up a customer is related to what? The number of items purchased. So time, which is T, is equals to the number of items purchased plus 17. Again, time, which is equals to T, is equals to the number of items purchased plus 17. All right, so it says, if it takes 19 seconds to ring up a customer, how many items are being purchased? So we know that T is equals to P plus 17, but we're told that if it takes 19 seconds to ring up a customer, that means time here, which is this T, would be equals to 19. So again, I'm gonna sub T for 19, okay? Is equals to P plus 17. So here, what did they ask? How many items are being purchased, which is this, P. So we're solving for P, the number of items being purchased. So here I need to get P by itself. So I'm going to subtract 17 on both sides. Those cancel. So I have P is equals to 90 minus 17, which is 2. Oh, got 90 minus 7. So what is this is saying? This is telling me that the number of items purchased is 2. So it said, so here I'm going to say that the number of items purchased in 19 seconds is 2. Boom. That's a part of my answer. All right, so this should be getting easier and easier as we go along. So yeah, let's go ahead and look at the last example right here. So model problem 3. This equation shows the cost of Trevor's retirement party depending on the number of guests he can have. So C They tell us that C represents the cost in dollar is equals to 5 times G. What is G? G represents the number of guests. So the cost is equals to 5 times the number of guests. It says, what is the maximum number of guests that can be at Trevor's party if he spends $15? So again, what do I know? I know that C is equals to 5 times G, okay? C represents the cost. So it says he spent $15. So I'm gonna replace C with 15. So 15 is equals to 5 times G. And they ask me how many what? What's the maximum number of guests that you can have? So I'm solving for G, which is the number of guests. So here, in order to get G, I have to divide both sides by 5. So G is equals to 15 divided by 5 is 3. So the maximum number of guests that Trevor can have if he spends $15 is 3. So Trevor can only have 3 people over, so he might as well just go ahead and have a Zoom party. All right, again, if you have any questions, feel free to reach out to any one of us as teachers. I will be more than happy to help you guys. All right, y'all have a good day.